Alright, we are going to look at number 81 from your packet. 81 gives us two functions. It gives us f of x equals natural log of x squared, and it gives us the domain for f of x, which is x is greater than 0. It also gives us g of x and the domain for g of x, which is x is greater than or equal to 0. And then it tells us that h of x is the composition of f with g, so that's f of g of x. And it tells us that k of x equals g of f of x. So for part A, we are looking at finding the domain for h and an expression for h of x that does not contain the exponential. This means we're going to have to simplify. So we know h of x equals f of g of x. So when we look at this, we are plugging g into f, which I'm going to go ahead and do first, and then I'll talk about the domain. So this means that we're going to have natural log of, instead of x squared, we're going to have e to the 2x squared here. When we raise a power to a power, we multiply the exponent. So this is natural log of e to the 4x, which is going to just give us 4x, because natural log and e are inverses of each other. They cancel each other out here. So our expression for h of x is 4x. The domain is a little bit trickier here. We are told that the domain of the inside function g of x is going to be x is greater than or equal to 0. So we know that has to be true. But we are also told that we have a domain of the outside function, which is f of x. So let's think of it this way. Whenever we found f of g of x, the domain of f was x is greater than 0. But when we found f of g of x, we took out the x that was here and we replaced it with e to the 2x. So we can also do that here for our domain. So we can erase the x that we have, and we can plug in g of x, which is e to the 2x. Now, in this case, e to the 2x, we would want to solve for x. However, if you try to take natural log of both sides, you cannot take the natural log of 0. If you think about this expression for a moment, it has to be true. You have e raised to a power. E raised to a power is always positive. It can never be 0. It can never be less than 0. So this is a statement that is always true. Thus, for our domain of h of x, we are going to revert back to the domain of the inside function, which is our g of x, which tells us that x has to be greater than or equal to 0. So for our function h of x, the domain is going to be x is greater than or equal to 0. So that was part A here. So let's move on to part B. Part B asks us to do basically the same thing, but this time we're looking at k of x equals g of f of x. So this one's going to be a little bit different. So let's go ahead and find the expression first. So we've got g of f of x. That means we're going to start with our g function, which is e to the 2x, but instead of x, we're going to write natural log of x squared here. So whenever we do that, we can bring this 2 into the natural log as an exponent. Those are properties of logarithms that we can use there. So this is e to the natural log of x to the 4th power. Then e and natural log are inverses of each other, so we are just left with x to the 4th power. So k of x equals x to the 4th power. For the domain for this one, the domain of our inside function is x is greater than 0. So we know that all of our x's have to be greater than 0. However, we also have to consider how that relates to the domain of the outside function. So the domain of g was x is greater than or equal to 0. That was our domain for g. So whenever we plugged f of x in, we took out the x, we replaced it with a natural log of x squared. So we're going to do that same thing for our domain. So I'm going to erase the x. I'm going to put in natural log of x squared. And there's a couple ways we can solve this. What I'm going to do is I'm going to pull this 2 outside, which gives me 2 natural log of x is greater than or equal to 0. I can divide both sides by 2. So I get natural log of x is greater than or equal to 0. And then I'm going to raise both sides to be the power of e, which is going to cancel out your natural log here. X is greater than or equal to e to the 0 power is going to be 1, because anything to the 0 power equals 1. So our domain of k of x is going to be x is greater than or equal to 1. Notice that that is a restriction that's more restrictive than x is greater than 0. Anything greater than or equal to 1 is also greater than 0. So we need to use this restriction here rather than the domain of f of x. Okay, so next we'll move on to part C, and part C asks us to find an inverse and also asks for the domain. So for f of x, we have f of x equals natural log of x squared, and they tell us that the domain for that is x is greater than 0. That part is given to us in the problem. What we need to know, since we're going to be switching our x and y's, is we also need to know the range for this. So we need to know the values that are possible for y. And if you think of the graph of a natural log, the graph of a natural log looks like this. And we are squaring our x squared, but that is not going to affect the range of the y values that we can have. So our range for our y values is all real numbers. Okay, so our range is all real numbers. That's going to be important when we switch our x and y's. So f of x, we're going to replace that with a y. Then we are going to switch our x and y, so we'll have x equals natural log of y squared here. And when we do that, if we think about domain and range, that means our x and y switch there as well. So our domain will now be x equals all real numbers. And our range will be y is greater than 0. So we can see that our domain and our range just switched values here. They don't ask for range, so you don't have to write this, but I just put it there because it helps me remember that those switched. But the domain for our function is going to be x is all real numbers. We need to finish solving this over here for y because we have to denote it as an inverse function, so it has to be solved for y. So I'm going to pull this 2 out as a coefficient because my properties of natural logs tell me that I can do that. So x equals 2 natural log of y. I'm going to divide both sides by 2. And here we will see that we have x over 2 equals natural log of y. To get rid of a natural log, we make something a power of e. So we'll make this side a power of e, which will cancel out the natural log. We'll also make this side a power of e, which will give us e to the x over 2 equals y. So our inverse function we're going to denote with f inverse of x is going to be e to the x over 2. And then, of course, we have our domain is up here. X is all real numbers.